Hello everyone, welcome to the little barn. I think everyone are already sitting comfortably, very good. So we will have Kevin OTTENS from enioka Haute Couture, sorry about my pronunciation, explaining us about crossing the QtWidgets to QtQuick. Go ahead, Kevin. Big hands to Kevin.
Thank you. Welcome, everyone. I hope you're past the post-lunch slumber in this session. So we'll have a few slides, but there will also be some code, so we need your attention. Before we start, a couple of words about yours truly. So my name is Kevin OTTENS. Despite my look and my name, I'm actually French. I've been developing with Qt and I've been contributing to the KD community on and off for 20 years or so. I, in particular, contributed to Qt itself for a little while and to Qt 3D in particular. Before that, I actually got a PhD in AI before all the hype. So I kind of missed a time window or something. And I've been involved in many different type of projects ranging from embedded to enterprise IT systems. And I'm also a trainer. So at training sessions, I probably trained hundreds of engineers and students because I did that at the university as well. I'm one of the KDAB alumni, so I'm not working there anymore. But I did for quite a few years. And nowadays I work for enioka Haute Couture, which is a service company as well, but not necessarily focused only on Qt. We play with plenty of different type of stacks, and we are putting quite some effort into software engineering in particular and the practices around them. And I'm currently living in Toulouse, and I'm basically a remote worker. So why this talk? Well, one way to say it is because Volker Itzmayer made me. Yeah. So the Qt chief maintainer was, for some reason, attending one of the trainings I do during the KD conference. I do a small training for new contributors about the KD stack so that they understand how that works. And I had a couple of slides there where I'm rambling about software architecture between QtQuick and QtWidgets. And then he came to me during a break and he told me, "Oh, that's very interesting. You should come to also talk about that." So I took those two slides, and then there was room for expanding. So I took those two slides, and that's basically what you're going to see there, an extended version of that, and we'll go more in details about that. The other reason, obviously, is why I wrote those two slides in the first place. It's that there's questions which keep coming back when I see customers which are, well, we are QtWidgets code and we would want to move to QtQuick, and it's not that easy, okay? So how can we do that? In the end, that's, in my opinion, a software architecture conversation. That's what we are going to have here. And turns out I like software architecture. So in this talk, we will compare two software architecture patterns as we find them in applications when they come from QtWidgets or from QtQuick, and we will see a way to propose path at least to refactor from one to the other so that you can actually do that. All right, so the first case, that's QtWidgets itself. If you make an application with QtWidgets, very often you end up with something which, if I simplify it, would look like this. You would have this pattern, which is kind of repeated over and over in your application, okay? So it's, you have many model classes, probably, okay? And those, they have signals and slots. So we're in a barn, but there's actually a truck coming, right? A tractor coming. The communication between the model and the widget would be signal slots and probably some method calls on the way down. The widget will be C++, the model as well. That widget inherits from QtWidget. That's generally what you have. Very often you also have a UI file which generates some more C++, and then it's plugged on the widget part via signal slots, very often both ways. Now, two important things to keep in mind is that that link that might be this part creating that model, very often that's also something which is passed from the outside, or you get a handle or something to get to the model part you're interested in, and that widget creates the view. Okay, that's very often what you got. Again, that's repeated over and over in the application, and you will have numerous models, widgets, views. What's important to keep in mind that you might have complex relationship between model and widget classes. Okay, you might have one of those widgets which has several models, those models being used in different widgets and so on. Now, one thing is though is that this widget has only one view, okay, and it creates it. That pattern, so if you see here, I wrote control. That pattern is because it's kind of, when I say model here, I'm not thinking the abstract item view model. I'm talking about a model of the domain in general, okay? And that pattern that looks very much like the good old MVC pattern in architecture, okay? So model view control. So that's why I put this little control note there, okay? I tend to call that the MVC with a twist, because the twist is there. That's a control part, but that inherits from QtWidgets, right? So I'm kind of tied to my GUI framework on my control part. And also for that creation, because that's not necessarily what you find systematically in MVC, I think that coupling is generally much less tight. Code-wise, you would write something like this, okay? You inherit from QtWidget, you have your constructor. In that constructor, you create the object coming from the UI file, call setup UI on this. Then in here, you probably have a bunch of connects, okay? That the links between the view and the control, which I was mentioning before. Then you have a way to actually set the model that you will use within your widget. And before keeping that pointer, you probably have a bunch more connects for the links between the control part and the model part that I was mentioned. Okay, so that's very often what you will have in your structure. Then you put it all together, create a new widget, create a new model, set the model on the widget, show it. Okay, that's pretty much how it is. Now, if we look at QtQuick application architecture, we'll have something which is more like this. We'll probably have that model part still, okay? That part that's similar to what we've seen on a couple of slides back. Then we will have something which I will call a proxy or service. I will probably stick to the proxy name in the rest of that talk. But sometimes in real base code, you find the service naming more used. And so that one will expose properties on the QML side. Okay, here we're changing language. And through the property bindings, we integrate that into the view. And then we have the methods calls. Okay, one of the big changes we have there is that very often what you have is that you write the QML, and from the QML, you refer to an object which is coming from the C++, which is probably that one. Okay. So the relationship goes the other direction compared to what we've seen just before. It's the view saying, okay, I need that piece of control, if I keep calling that control, okay? Again, we have several classes of each type. That pattern repeats over and over. The big difference, though, is that, we can have the same kind of relationship that before. So those are a complex relationship there. But we can also have a complex relationship between views and proxies, okay? Because that view here could create as many proxies as it needs, okay? So there's less coupling between those two. That type of architecture, so I kept the name control for you to follow, okay? But that type of things, that's generally what is referred to the MVP pattern, okay? So model view presenter, that's generally the way you would structure that. Code-wise, now we lost the dependency on anything graphical. That's pure Qt core. Okay, we have QObject. We have the properties that we will want to see usable on the QML side. We might have this one to say this marker to be able to easily expose that on the QML side. Probably a constructor, getter, setter, signals here, okay, to satisfy those properties above. And then internally, you have a way to get to the model bits that you need for that proxy. And we could easily imagine something like this, doing some work to locate the right object based on an ID or that we passed from the QML side, or maybe that was coming from the C++, but we set it from the QML side. Then the view part, you would have something like this. So you import QtQuick, obviously. If we assume that the proxy we've seen just before is registered in a module that we called or.kd.app, then we can mesh the two together. We'd have a regular item, another item. Then we can have our proxy, give it an ID, say, well, the model you're working on, that's with that string, figure out how to get to the actual domain objects. And then, so we are setting that property, but we binding to that property so that if something changes in the model, okay, via the proxy or so on, then we will react to it. To put it all together, then that's basically you have a QQML application engine. And if we assume that the view that we've seen on the slide just before, so the view QML is registered as well in the module, then we can just do a load from module name, the view, and then we're started, okay? So that's the code side of that. So with that, we've seen like two different patterns, okay? There are some similarities, but there's structural differences there. And that's the two anatomies of applications when you started them either with QtWidgets or with QtQuick. So the pattern used for QtWidgets, in my opinion, get a bit in the way of reusability. As I mentioned, it's similar to the model view control pattern, but with a twist again. That twist is very convenient if you're thinking, I want to compose my application out of widgets, because then all my control parts, if I want to combine them, they are widgets, right? So I can just combine them with the widget tree, and then I'm fine and I'm happy, okay? That's true. That's very convenient as long as you're thinking only that way. But by doing so, you're actually overfitting the pattern that you're putting everywhere in your application. You're overfitting it to the needs of QtWidgets in a way. That doesn't have to be like this, okay? There's nothing which forces you to stuff the business logic inside of that widget, okay? So that's what we will see. We will want to separate this. The pattern we use for QtQuick-based applications, in my opinion, is superior because then you get less coupling between the view and the control, as I tried to highlight on the diagrams before. And when there's some coupling, it goes, in my opinion, in the right direction. That is from the view towards the proxies, okay? And that's probably okay because the views, that's on top of your application in a way, and that's where you have the stuff which is the most specialized. So that's okay to have it that way. But the other direction, like we have on the widgets, assuming we put inside of the widget the business logic, I'm not so fan of. And so, as I mentioned, that's more akin to the model view presenter pattern, in my opinion. Now, the question is, how did we get there, right? Why did we get kind of stuck with that MVC with a twist on the QtWidget side? We could have decided way back, okay, as I mentioned, I've been doing this kind of stuff for 20 years. We could have decided to say, yeah, but that dependency is weird. Maybe we should do things differently. And maybe we would have like a structure which is a bit more like the QtQuick ones. Well, very often that's for historical reasons. We were young, we were stupid, we didn't know any better. We did that, okay? The problem now is that we have lots of legacy code that we have to deal with, which is done that way. The other reason is that if you look at the official Qt documentation, Well, you're doing exactly what the Qt documentation is pushing you to do. You take any example in the Qt documentation, how-tos and so on, they're all structured with the MVC with a twist. So that's your first Qt project. Your boss tells you, okay, you need to do a project and that needs to be with Qt and that would be widget-based. What do, right? You get to the documentation, you get the first how-to, and the Qt guys, they are smart, and so you're following what they are telling you to do. The reason why they do it this way, though, is that those how-tos are small, okay? So you don't see the price you're going to pay much later when you keep repeating that over and over in a larger application. So that's a bit of a trap that is embedded in the documentation. Now, is there any hope there, right? Do we have tools to actually help us with that? So my answer would be yes and no, as you will see. So actually a decade ago, so another Kevin, not me, Kevin Kramer from KDAB, started the declarative widgets effort, which is still available on a public repository there. It never made its way, so it's separate thing because it never made its way to QtWidgets. Back then when he started, I think his idea was to actually advocate for that to end up in QtWidgets itself, but never was the case. The idea of declarative widgets, if you don't know it, is to provide a QML API for widgets. Okay, a QML-based API and not only a C++ one. The problem with the fact that it's outside of QtWidgets means that for the implementation, it needs to rely on object extensions. So if you use it, indeed, you can write QML code for your widget parts. But then you get all those object extensions, and that's priced in memory at runtime. It definitely helps with redoing an existing QtWidgets GUI that you've written. You got the UI files, and it will nicely redo the UI files in QML for you. There's a small tool to help with that. So that helps with that step. Now there's another effort which is more recent, which is the Qt bindable properties, which have been introduced on the C++ side, because this way we get the property bindings also for C++. So that could be a way to help as well. That's supposed to make actually the MVP pattern easier to implement, but on the C++ side without even thinking about QML. So we could try to do that with your Qt widgets. Problem that no widgets actually use this. Now, those tools are here. The way I present it, they kind of didn't make it, right? They not widely used in QtWidgets itself, which is kind of a limitation to their use. But even if they made it, what about your code? Because your code is still stuck in all the QtWidgets that you actually wrote, right? Those, they help with the last layer of Chrome of your application, but they don't really solve the fact that you got all that business logic which is trapped in your own widgets. So they are nice. They help to, get started, but then you're missing quite a lot of details, right? There are still those details of how do I save my business logic from the existing code. So I swear I didn't know we would be in a barn. And that there would be a theme about horses everywhere on that venue. Still, that's the meme I picked. All right, so now let's add the details and let's see how we could do that. So a disclaimer, it's not a real live coding because otherwise I don't fit in the session time, okay? So I will be cheating a bit. I will jump between versions of the code as it progresses, okay? Which can make you a bit dizzy, but I will try to focus on the important parts which changed between each step, and the one which makes sense from the architecture there. One other caveat there, don't do that at home, in the way that here I will completely skip the question of tests, okay? And you should never do what I'm going to show you without having a strategy for your tests next to it, otherwise you will introduce regressions and so on. You need to have those tests to keep things safe. I do those two simplifications for speed reasons. If you're interested in the aspect of the test and how you do that safely and for such a refactor, please see my previous talks that I did at World Summit or DevCon or this kind of stuff a few years back. I actually covered that in more depth there. Or shameless plug, as I mentioned, we're a service company. I'm doing trainings. We have workshops on exactly these kinds of topics, and you can spend like half a day, 1 day, 2 days talking about this kind of stuff with me. All right, so here is the code. I will first actually run that quickly so that we have an idea about what we're talking about. So let's imagine we have a little application here. We imagine we have a catalog of products, okay? Those products, they have a name, selling date, and quality level, okay? That's the basic idea. Out of that full list of catalog, I can choose one of those, okay? And when I choose it, I get the value for the remaining days before I need to sell that product, otherwise it becomes stale. That's basically the idea. And its quality level. I can then modify that value, okay, and that updates in the full list. And if I click that button, that will trigger my weird business logic. I'm not getting into the detail, but you get the remaining days and the quality to evolve. So every time I click, one less remaining day for that product and the quality changed. And there are rules for the quality to vary. So for instance, here we will go down, okay? But if you turn out to be brie, then your quality will actually increase even past the selling date, because who doesn't love a very old cheese, right? That's basically the idea. All right, so now let's see the code behind that. So we'll have a few classes. We'll have a couple where I won't show you the implementation because it doesn't matter for today. So first we have one which is an item. So that's one of the items that we got in our catalog of products. The items, they basically have an ID so that we can refer to them. They have a name, selling date, the number of days remaining, and the quality level. I can get to those properties, check the equality, and so on. Then I have something which I call a repository. So in a real system, that would be something wrapping the access to database, say, okay, and then you would have access to all the products inside of your database. Okay, we can imagine something like this. And so it would provide services to get to some item based on some criterion. So here we have something very simple. Either we get everything or we get based on a single ID. When I got one record out of my database and modifying my item, because you remember we get the values to change, then I would need to save it back to the database at some point. So I have a service to say, okay, that record I had before, now I want you to save it in the new state. Now, more interesting for our conversation today, we got a UI file. We got then the window, okay? And that will be done the old-fashioned way. So it will have the control, business logic, and so on. It inherits from QtWidget, as I mentioned on the first few slides. It will have a bunch of slots, which are the things we will connect to the widgets coming from the UI file to react to have some behavior. And we will have some implementations internally to finish having the whole behavior of our application, okay? To do its job, it will have access to the repository, obviously. It will need to list the items, and it will also memorize what is the current item which has been selected by the user to be able to modify it, to save it back. Now, implementation-wise, that's the structure I mentioned earlier, okay? We have a constructor. We're creating the UI object. We're calling setup UI. We have a bunch of connects, okay? Those connects are they're every time going from one widget signal to one of the slots internally. And a bunch of them we call preemptively to be in the right state at startup. And then that's no big surprise. If the current item changed, so I change something in the combo box, I get the ID, ask the repository for the item of that particular ID, and update the fields. That I take the values from the item and I put them inside of the spin boxes that we've seen. When the quality changed, that means one of the spin box changed, well, then I update my current item based on that value and I save it. And I update the table so that you actually see something in the table at the end. We'll quickly see why that's needed. And then same thing for the sell-in. And when I click the button, I get to the update current item quality, and that's when I have my weird legacy, badly written logic. Okay, everyone has something horrible hiding in the closet like that. Save the item, update the fields, update the table. Update the fields, that's trivial. Update combo box, that's where it gets nasty. Update combo box and update table are both necessary because I said I went the old-fashioned way. So I have no abstract item model. If I don't have that, then that means I get everything. I copy it in each of my widgets so that they display what I want. So here I'm copying the name and the ID to have all the entries in my combo box. And here I'm copying name, sell-in, quality, and save those in each row of my table. And then every time I update, okay? So hopefully you don't do much of that anymore, but I still see it sometimes in the field. So I prefer to mention that might be one of your cases, okay? Now, if we got this, obviously to me, the first step should be to actually solve that, right? So we introduce an item table model, and that will be the one which is between my combo box, my table, okay, and the repository. So I don't get into the implementation of that guy. That's a regular abstract item model that you might want to implement. And we will have something here to say, well, from time to time, we need to say, well, something probably changed in the database, so please signal whoever is watching you that something changed. That would be what reload data is for, okay? Now, once I have that, the next step I want is to actually start using it, okay? So now if I get back to the beginning here, I have my item model, and then I just set it. So I will just build that, otherwise the ID is confused. I will just set it to my combo box, and I switched, so I didn't show it, but I switched in the UI file from using a table widget to a table view. And so same thing, I set that model on the table view. Apart from that, not much changes at that stage, okay? The only thing which really changes is that you see the update combo box disappeared, and the update table that becomes just, well, signals everyone that something changed in the database. All right. Now, next step is to introduce another one. We need, as we've seen from the implementation, if I get back to the window.h, we have now the table model, the repository, and that current item here. Here we're having that widget which get to the naked object, okay? We need a way to start to decouple this. So we will start putting someone in between to moderate that access, and that's that item proxy that we're introducing here. And that one will represent one of the records, okay? But then wrap it into a QObject interface, okay? So we'll have a bunch of properties, like the ID of the current item, the name, sell-in, quality, okay? If you pay attention so far, that starts to look, and I named it proxy, right? That starts to look like what I was mentioning we would have on a QtQuick-like application, okay? So we will have a way to, same thing, reload the data. We can change the ID, the item ID. We can get to the current item and so on, okay? We will look at the implementation of that one a bit. What's important there, most notably, is like reload data. That means, well, something changed in the database, so the record I got out of the database is stale, so I need to query the database again to have a fresh one. That's what we are doing here. If we found out that it didn't change, we don't do anything. Otherwise, we memorize that one and we say, hey, look, my properties changed now. Okay. Same thing if we set the ID, well, then we get to the item with the new ID. Okay. So someone says, now the current item is a different one now. Okay. And so we will emit the signals there. Once we have a proxy like that, so for the name, set name, and so on, that's like more traditional stuff. Okay. I'm just changing one value at a time. Once I'm there, I will then get to, so once I'm there, I will start to use it. Okay, so I don't have my naked item anymore. I will have the item proxy in the middle. And then in the implementation, I will start using this, set up the UI. And now that's where we start to see some change, right? So that's the connects I had before from the widgets to my slots internally. And here we will have the other way around. That is, if the item proxy tells me the selling change or the quality change, then I'm impacting the spin box. So now we start to have like bi-directional connections. Otherwise, I set the model as before. The update table, as we've seen, is trivial. And then the on-current item changed. Basically, that's the one we changed a bit. There, we just say, well, I set the ID on the item proxy and I have nothing else to do. The update field that we had before disappeared. Okay? Because now it's all done through connects, so I don't need something like this. And all the implementation there, they didn't change apart from just changing the item. I called the setter on the item proxy. Okay? Once I'm there, and we need to go further. I still have quite some business logic, which is still in my widget, but we're starting to decouple bits by bits, okay? So once I'm there, looks like I missed a step somewhere. All right, sorry about that. Sorry. Once I'm there, I will start to have another proxy, which will be the page proxy. So the one which starts to do the link between the item model, which wrap the whole database, the concept of having a current item, which I have in the item proxy. I will need to have something to mediate that. So we are having a page proxy here, which has the current item, which is an item proxy, which has a model, which is the item table model we had before. And that's pretty much it. And when something changes in the item proxy, we have this on-value change to react to it. And this one, we say, ooh, the item which is managed by my item proxy changed. Well, then I need to save it. Okay? That's why it mediates everyone. And because I saved it, now I need to say to the item model, time to notify that the data changed because I just saved. Okay? So now we got something which mediates everything. If I get back to my window here, okay, we don't have the model anymore directly. We don't have the item proxy directly anymore. We just have the page proxy, right? And now we start to shrink our window quite a bit. So I move that out of a slot and into a lambda, but otherwise that's pretty much the same implementation with a big change, which is the one on that line. I don't go to the item proxy anymore. I go to the item proxy, which is on the page proxy. The connects, we see, I group them differently here, but we got both ways for the selling, both ways for the quality, and the update button. That's the old slot that we have. And then we set the models. For that particular implementation, not much changes. Okay, we still have those rules. But if you look, that the only thing remaining inside of our old widget, right? We, as I mentioned, we're pushing responsibilities right towards the proxies slowly. And so the next step here would be to actually clean that up, right? If I take the implementation I had and I move it to page proxy, which is what we just did here, then my widget has basically nothing but connects and setting model, and then that tiny, very view specific how you resize your columns in the table, and that's it. okay? Now on the page proxy, obviously, I have more now, okay? I had just the on value changed. Now I also have the whole dance for dating the item quality, and we just connect to it the right widget to that part. So now that means that all my business logic is completely out of my widget, and it's spread among two proxies in that particular case, okay? Each with their own concepts and responsibilities. When we're there, we have an application which still runs, which is still widget-based, but we can start to do things like this. All right, so if I read base and if I run, I should have... It wants to, okay. So now we can start doing something like this. So we have the original, but with everything moved as we've seen inside of the proxies on the left. And here we have something which is not connected to anything yet, but a re-implementation in QML using QtQuick controls, okay? And so that would be this one. So we have the implementation, okay, based on QtQuick controls. I have column layouts and so on. What's important, and you should pay attention to for the next step, that we have a combo box with an ID. We have find the two spin boxes here. We have the update button, okay, and then we have a table view, okay. So now the last bit I need is actually just let go of the window, okay, and start using my proxy in here, which is what we have there, okay. We just say, well, that view, which had the right look and everything, it just creates the page proxy. And the current item ID of that proxy is bound to the combo box. The combo box has a model which comes from the proxy, the page proxy. The spin box has bidirectional bindings because the value of the spin box should reflect the quality of the item proxy, and vice versa. If I change something in the spin box, I want that value to impact the current item quality. Same thing for the sell-in. Same thing, and the button on-clicked calls the business logic that we had in the method, and we just set a model for table view, which is the same one than the combo box. Now, if I run that, I get something which looks like the proof that it's not widget anymore, that you see the style kind of changed, but we have the same logic as before. Okay, if I change the quality, I impact. If I click there, I get this to evolve. If I change, my brie is still improving its quality. Okay, but we did that transition, so in a few systematic steps, and that's how we actually managed to do that transition. So to conclude there, why would you want to do that? Well, the first motive, the one which I mentioned, is, well, I need to reuse something for a QtQuick way. Okay, that's the angle I gave when I started that talk. True. I mean, if you have that incentive, then yes, definitely we need to do this kind of work at some point. Now, I would argue that even if you have something which is QtWidgets based, going from that MVC with a twist to a MVP architecture in your application, even if it says widgets, that's worth the effort, okay? Because as we've seen, before I did the last jumps at the end, right? Our widget was very, very simple, okay? We spread we had a real separation, okay, of concerns between what was GUI and settings the state of the GUI and what was really about the business logic, which shouldn't have been there in the beginning. And so also we have then better reusability because then we can mix and match those different proxies that we introduced between the widgets, and there's less coupling. For crossing the bridge itself, what we've seen that unfortunately we don't have an existing tool which provides like a silver bullet to do that. We got tools, again, we got nice tools to deal with the last steps right? Where I would want to rewrite when I was at something where I did all the work of separation. So using something like declarative widgets to say, now I even let go of that widget and I re-implement it in QML. Sure, why not? I mean, that's a nice thing that declarative widgets proposes there. But I still had to do all that work before. The proposed approach here is, in my opinion, broadly applicable, and that's basically the 3 rules that you give yourself as you work toward that. First, so in that case, I'm talking about abstract item widgets. If you still have places where there should be an abstract item widget, because that's a collection of something and you didn't wrap it and you copy back and forth, please do that if you still didn't do it. Then once you have that everywhere, that was the first step, you write a proxy which adapt, you write proxies, actually you should have made that a plural, adapting domain objects and wrapping business rules, which were the last steps that we've seen. And then you can plug the existing QtWidgets GUI or QtQuick GUI at will. Okay, you could even have both of them still live and maintain them next to each other for a while. Of course, extra rule there, which I mentioned I skipped for today, but scaffold everything with tests. Okay, from the steps I showed you, there are plenty of ways that could have gone wrong. And now you can actually go and try to do that on your own projects, obviously at a different scale, but that gives already a direction for the work. And with that, I thank you for your attention.